I'm going to go ahead and get started making the pins for these rollers right here. This is for the barn door, and these are the bearings that go in there. So these are some 6204 20 millimeter ID. All right, so what I've got is some this is some stress proof that I pulled out of my rack out here. This is stuff I bought back in 2014, and it was a canceled job, so I had all this extra material. This right here is 1 inch, this is 1 inch, this is 1 3/16 right there, and it was very flaky, rusty. And you see this one piece right here, it was underneath all of it, and it's pretty rusty. I mean, pitted. So I just brought them over here, used the grinder and the vise, and just went ahead and wire brushed all the rust off of it. This piece right here is still good and clean. But we're going to use some, I want to use this 1 inch stress proof because that machined, it's a free machining material, so it machines good, it threads good, just really easy to get it where you want it. So we're going to use this piece right here, and we'll probably have to get into this piece as well, and it shouldn't be a problem. I'll just, you know, the head diameter on it isn't critical, so we can turn that down a little bit if we need to. All right, so that's what we're going to do. Let's go ahead and get on it. I decided we're going to go ahead and use up this bar that's got all the rust pits on there anyway. There's nothing wrong with it. I think it might give it a little bit of character around the head of the shaft that's sticking out the side of the plate there. It's going to have a couple flats milled on it anyway. So we'll use our 6-jaw chuck for quick convenience of chuck holding here. Let's just stick it out 5 inches like that. Go ahead and give the end a good face. Go ahead and create my first offset. So our first shoulder length is going to be 1 inch back. That's going to be for our threads. All right, let's go ahead and turn this end down to 1/2 inch. Let's take 100,000 passes here. So this is 400, that should leave us about 100 to come off. I'm going to finish it at 495. I've been using my Lufkin mic that I cleaned up here recently. I think I shared that over on Instagram. Had some rust on it, and I cleaned it up and putting it back to work. So all right, so that's 90, it's 592, so 97. We want to take 97 thousandths. Five thousandths into the shoulder just to clean it up, face it back by hand. And I just want to double check the diameter here. And I am good. I'm 5 thousandths under. So we're 495. It's a good size there. All right, so this turned area here that's going to go through the bearing is going to be 3.5 inches. So I'm just going to use my hook scale. That looks good. That is lined up. Make sure that it's nice and straight and parallel. And that is right on that line. So we'll set our indicator to 0. right there. Make our witness mark. Go ahead and take in another 100. That'll bring us to about 800 thousandths. So we want our journal here to have a slide fit through the bearing. We don't want it loose, but we want it to slide through. And it's going to be 20 millimeter, but we're going to turn it to 0.787. So we're at 792. So we don't have much to come off of there. I don't really like taking these really light cuts like this, but sometimes that's just what you end up with and what you have to do. All right, so we're at 789. I need 2 thousandths. All right, cutting nice and straight. Just double checking it. All right, so I'm going to take another 2 thousandths. So we're getting about a 1/2 thousandth taper there. This is tapering to the big side right there, so we'll have to do some polishing there. Let's go ahead and we'll do our chamfers first. Use our MCH&N tool. Put a nice chamfer there for the thread on the end. Break that corner and then break this corner here. We're going to use this 1/8 wide radius tool to make an undercut for the thread. That's a top-notch type of tool there. Sorry, we just touched off. I'm going to plunge it 105 thousandths deep, double depth for, if you just use your fishtail gauge right here, 13. It says 100 thousandths, so I just give it usually about 5 thousandths extra. All right, we're going to blend it in that corner radius there. And then I'm going to move it back to my right side a little bit more to widen out the groove width. And I'm going to use the compound to feed it back at 30-degree angle, just like that. I got a little bit right on that very end I need to get, but that's a pretty good slide fit right there. Okay, let's go ahead and start our threading there. So we'll go ahead and share our tool that we're going to use. Here's our insert tool. The insert that we're going to use, that is the 16ER AG60 threading insert. And so this is my 1/2-13 go, no-go gauge, and on the go side, see, they always list what your pitch diameter is for both the go and no-go. So this one has your pitch diameter listed at 0.4500. All right, so you can use this to measure with if you have a proper pitch mic. So I have, this is my Starrett pitch mic. This one's listed for 10 to 13 pitch. So you can use this to actually measure your go gauge right there and verify it. Now, verifying it with this mic, I'm actually measuring it at 451. That's the closest I can measure it. So I will actually thread this and mic it at 451. And all that's going to be going on these is just standard hardware grade half 13 nuts. So, as long as the screw's on there and we got a good fit on our pitch mic, that's all we need. All right, let's get this thing set up. So we want to cut a 13. We're going to be BD7 according to my chart. So BD7. That's it right there. I've got my cross slide set to 0, and we've also got a dial indicator set to 0. I have a problem with this lathe being what I call spongy, and I haven't gone into it to find out what exactly is causing it. But sometimes when you go back to 0 right here, it's actually not in the same position. It could be off a little bit, like it might be. And whenever you go to this 0, you're in fact, you could be in another 10 or 15 or maybe even 20 thousandths, and you don't realize it, and you're cutting a lot deeper than what you think you are. So best way to avoid that issue is to go ahead and set you up another indicator right here so that you go back to the same 0 every time. So right there, it's 1/1000ths difference every time when I go back. So you can use it just to kind of verify it. So you can just go back to this 0, and I'm showing 1/1000ths difference right there. So it works out really good if you just do it that way there. For me anyway, on this machine. So we'll go ahead and move our compound in to touch off. Now another important thing to remember. All right, we're already zeroed out on our compound there, and I'm going to make a scratch pass. So on our threading dial, I can hit every other number on the threading dial. Okay, so on my thread dial here, you can see I have 1, 2, 3, and 4. You also have positions in between that, so you have a total of 8 positions on mine. So on an odd pitch, so we're cutting a 13, that's an odd number, you go every other line. So if you start on a number, which I'm going to start on number 1, you can hit every other one. So if I start on 1, I can engage this half nut on 1, 2, 3, or 4 anytime, and it will line up. I can't, if I start on a 1, I cannot hit the ones in between, or I'll split the thread. Okay, so odd pitch, every other one, depending on where you start at. That's what you got to remember. So this is our scratch pass, and that's always to verify that we have our machine set right. And we're just going to check it with our thread pitch gauge right here. We've got it set to 13, and always verify it, and we are correct. Okay, so, and I'm also going to prove my point. There's number 2 on the thread dial, and you see that it lined up. It did not cut in between the threads, so that I can hit any other number. So let's go ahead and make a cut now. I'm just going to go ahead and make a series of cuts and get this thing on down. I actually forgot to dial in right there on the compound, I mean. Just going about 10 thousandths on the compound now. Let me give you guys a shot of me working the hand wheels, because most people like to see that too. Total depth in feed for the compound is going to be right around 57 thousandths. So I'm right at 50 thousandths now. So once we get real close, we'll start checking it with our thread mic. Go ahead and file the top. And we'll go ahead and give it a mic. We'll get in here with our pitch mic and see, we should be getting real close. It's always kind of hard to give you a good shot of micing just because of trying to give you guys an angle and me being able to get in here and see it as well. So I'm measuring that at 459 with the pitch mic. So we still got, I'm going to call that about 8 thousandths to go. I like to just, I'm not filing it hard. I just want to make sure that I remove any burr off of the thread from that tool rolling over, because that's going to mess up your measurement with that pitch mic. I think we're going to be right where we want to be. That's measuring 401.5 right there. So I think that's going to be, good. Our standard hardware nut fits it just fine. Alright, good deal. Alright, so now that we got one done, my plan of attack here with this bar, I'll go ahead and bring my zero around to the top, is to flip it around and do the other side. Oh, look at there, like magic, that side's already done. So since that's the case, we'll go to the saw and we'll go ahead and cut both ends off. We'll have two of them. We'll come back to the lathe and we'll have two ends that we can go ahead and start machining two more. I'm just going to cut the heads of the shafts here about 1/2 inch wide, and then we'll face them off just a little bit. Double check it there, 1/2 inch. Alright, there's a couple more of them there, so we've got 4 down, so I got 6 more to go. I'm going to keep knocking these things out, and I'll bring you guys back whenever we're ready to get to our facing op. Alright, here's our final 2. Just got them cut off in the bandsaw. And what I discovered is that other piece of material that I thought was stress proof was actually 1018 cold rolled. These two right there. I don't know if you can tell the difference there between the stress proof and these pieces here and this one being cold rolled there. But anyway, they all look the same there except for the end being a little bit more corroded there. So now we're just going to go back to the 6 jaw, clamp them up, give them a nice face cut, then we'll set them up in the milling machine. We're just going to mill 2 flats so that he can put a wrench on this side and be able to tighten the nut on that side there. So we'll get them faced off first. Now here's a little bit of a telltale sign. If you look at the corner radius there for the undercut, and all these, you can see it's a little shiny. You get down here to the left too, not quite as shiny. It's an easy way to tell the 1018 from the stress proof material. The head is approximately 1/2 inch thick there, so I'm just going to take about a 1/16 off of it. We'll just make them 7/16 wide is what we'll do. So we'll just put them all the way in there against the jaw. This one's pretty simple, so since I went up in the shoulder, I'll just pull it out and measure it. Once we get this 0 set, I'll know exactly where to go. So we got about it's 22, about 25 thousandths is where we got to come off there. Reset a 0 over here. Come right back into this 0. So we'll just go ahead and face all 10 of them, then I'll come in there and chamfer all of them. Go ahead and check it and see if I landed around on 437 that I wanted. Pretty close. 437.5. I think that's close enough to 7/16, isn't it? Let's go ahead and get the next one in there. We'll cut it and see how close we get to it. Look at that. Spot on. All right, I'm going to finish the other 8. Alright, we're going to finish this thing out, get the 2 flats milled. So I'm going to use my 8-inch super spacer here. This is a Vertex brand super spacer. And for anybody that don't know how this works, this is a 3-jaw scroll chuck on there, so it's self-centering. And you can use this like a rotary table also, but the way I have it set up is that you pull a lever over here on the back side that takes it out of being locked, and you can rotate it around like this, and you let go of the lever. All right, and you can click it in, and it'll actually lock in every 15 degrees. All right, there it is, locked in. All right, so the 0 mark is actually over here on the back side. It's made to be positioned around here on this side, but I always like my tools on the left side of the mill. It's just my personal preference. So all I do is just I have a blue mark up here at the top. You just have to have a reference on where you want to look at the divisions. So I use 0 and 180 for this. All right, so I'll just bring it on around to 180s over here, and I let go of the lever a little bit beforehand, and it'll drop in. So I've got my 2 blue marks lined up, and then lock it in, and we're ready to go. That's the lever right there that I talk about that you have to pull up on to disengage the lock so that you can rotate the chuck. Well, here's the lock. So you got to pull that one around, pull this lever, and allow you to index it. That's just the indexing pin. So here's my blue reference mark. I also use this ball oiler as the top center there as well. So we want to bring it around to 180. Just drop it in right there. So we'll cut our flat there, and also come around here to our 0, and then drop it in right there. So we're going to mill it to fit a 7/8 wrench. I've got a 7/8 wrench here that we'll use to fit it there. Just going to space it off the chuck about 1 inch. Alright, we're starting on 180. I've only got 1 pinion on this, this 3-jaw, so I just start right there where I can tighten it up. Bring the knee up until we touch. All right, there's our touch off right there. Zero it out. So what we'll do is we'll start with 50 thousandths. Let's cut 50 per side, that'll be 100. Just go ahead and stop it. I don't like getting my hand in there by a rotating cutter. All right, so let's go ahead and rotate it around to 0. All right, we got our mic, so we want to end up on 875. And where are we at? So we are at, so we have 18 thousandths to come off of it to bring it to 875. So that's going to be 9 thousandths. We want 18 total, so we're going to bring it up another 9, 5, 6, 7, 8, 9, and we'll cut it again. Alright, that's 875 right there. Here's our 7/8 wrench. Fits it just like it should. Alright, good deal. So we should be set now. Now we can just do our little production run. Just clear our chips there. Put it back about in the same place. All right, we'll repeat. Alright, see now I got to bring it back around here to 0, I'm sorry, 180, because of the one pinion on this chuck right here. Alright, so I'm going to blast through these and I'll bring you back when I'm done. Alright guys, we got all the flats milled on our pins here. All that is ready to go. Okay, so just about done, and I actually thought that we were going to be through with this job. So I actually kind of messed up here when I first started this job, and I did this piece right here. In the very beginning, in my mind, I kept thinking 3/4 of an inch. We had mentioned 3/4 of an inch, and when I did this hole, I said 3/4 of an inch. And it was just a mistake that I made thinking 3/4 of an inch, but this is this should be a 20 millimeter hole for our pins to go through, and I drilled it 3/4 of an inch, but we have a 20 millimeter hole for our pin to go through to fit our bearings. So I'm gonna have to set these back up in my mill and open these up to a 20 millimeter hole. So that's what I'm going to do now, is go ahead and set these back up. I'm going to use my same setup that I had with the vise and you know, my jack, and just go in there, probably just use an end mill. We'll get it centered up. It's not very much, it's got to come out of there, and just use a 20 millimeter end mill and open those back up. Alright, we've got my little production set up again here. It's going a lot quicker though, so just opening these holes up. Got her clamped in here, and checking the level with the little steer it level there, which we're good. Got our planer jack set. Clamp this down to add some rigidity to the setup there. and then we'll put an indicator right here to go ahead and indicate the hole true. All right, we're going to use this little InterRapid test indicator right here. My favorite little setup for indicating holes like this in the mill. I like it because it's got the indicator face on the top so that you can always see it. All right, that's going to be pretty well centered right there. We're going to lock the table in. So we're going to put in this 20 millimeter 4-flute end mill. We'll use this to cut the hole. That's it. Let me grab a pin and we'll see how it fits. Close fit. I think I got some chips down in there. There we go. I think that's going to work right there. Very cool. Okay, well, I've got all the brackets re-drilled to our 20 millimeter hole there. So all of them are fitting like they should, just like so. All right, and then it'll be like this. They'll probably just have a washer on there and then just a hex nut. It'll be like that. So we're going to go ahead and press the bearings and the wheels now. These being the wheels, so they supplied the roller bearings. So we'll just go over to our arbor press, and some of them just go in just like that, but some of them are a very light press, so it really won't take much to put them in there. We'll go ahead and install all the bearings, and we'll just go ahead and assemble one or two of these so that we can see what this will look like as a finished product, okay? We're going to use the Greener number 3 and just lightly press these in there. The customer only gave me a small amount of these bearings. I thought I had more than this, but so we'll only be able to install maybe half of these rollers here. So I got this little plate that I faced off that I'll be using to press these in. And they're not really a heavy press fit at all. Like I said, I didn't make these rollers, these wheels. I think they just machined them like the same diameter as the bearings. Yep. I'm just going to leave it up to the customer's discretion whether he wants to put a little Loctite on these bearings or not. I'm just putting a couple of them together just to show you guys. It really wasn't part of the job to fully assemble these things, but as easy as they're going together, I just thought I would knock a couple of these bearings in there. That one's actually a very, very light press fit. That one won't spin. Yep. So far, that's the only one that's got a pretty good fit on it right there. Let's put a couple of these things together and see what they look like. We'll use our big reed here to hold them. So it's going to go in there about like so. Let's see here. About like that. So there's going to be some spacing issues going on in there, and customer didn't really address that, didn't really talk about that, but that can easily be addressed with just some kind of washers or spacers probably bought from the hardware store. And you know, if that comes up there where that needs to be addressed, we can definitely work on that. I think probably some bronze washers would be a good fix for that, but you know, that's going to be kind of expensive to do something like that. But that's it right there. I've got it spaced so that there's no squeezing, except for a couple of them that are spaced out a little bit more than the others. So you can put the 7/8 wrench on the one side, and then the 3/4 to tighten it up, and there it is. That's all it is to it. So yeah, you got a little bit of float in there on it. So let's see, I don't know if I'll be able to hold that thing, getting it out of there. That's it. So yeah, just got to get it spaced in there, right? We'll go ahead and put one more together. Yeah, I think as far as the spacing goes, maybe the cheap alternative to come on, baby. There we go. The cheap alternative to get the spacing right would be just to probably order some 20mm washers and just get them spaced out in there on each side, on the inside, to get it the way it needs to be. I try to be selective whenever I hit record because of those sirens, and every time I go to hit record to do a segment, there's another ambulance that comes by. So that's just part of the area that I live in. They come by every 5 minutes. All right. Well, this one's done, and I'm getting ready to call them so they can come pick this stuff up. Hope you guys enjoyed following this project. And really the main aspect of what was asked to do on this job was really to machine the pins needed for this right there, and drill those rollers out, and then to drill the holes in the brackets there. So evidently they're going to finish drilling the holes in these pieces right there, and then I think the issue of centering this up, they can just figure that out themselves with just some simple washers on there. But it's going to be a pretty heavy duty bracket system for a barn door, so I think it'll look pretty good once it's all done. So that was a pretty nice project. I enjoyed making the pins there and sharing that a little bit, and using the 3-flute core drill for drilling them out. So hope you guys enjoyed. I'm ready to get on to a couple of the collaboration projects next, so hope you guys come back for some more, and we'll see you on the next video, okay?